Welcome. In the previous lecture, we have seen some subsets of R2. We have verified whether the set is open, closed, perfect, unbounded or not. In this lecture also, we are going to continue with the same. Here, the first thing that we are going to consider is a non-empty finite set. Okay, we are considering a non-empty finite set in R2. Okay, let us name the set to be E. And we will check whether this non-empty set is closed, open, perfect, unbounded or not. Here it is given that it is a non-empty finite set. We don't know how many elements does this E have. We have seen in the previous lectures, okay, one of the previous lectures, that a non-empty finite set has no limit points. Okay, that is, we know that this E has no limit points. Okay, if it has no limit points, then we can come to the conclusion that the set is closed. In that video also, I have told you that in order to be a closed set, all those limit points has to be a member of the set. If at all we have some limit points of that set, we can talk about it. Since we do not have any limit points, we don't need to bother about it. We can come to the conclusion that this set E is closed. Okay, and we have to check whether this is open or not. Since it is given to be some non-empty finite set, okay, this E may consist, for example, I am taking some arbitrary 1, minus 1, 2 plus 5i. Okay, that is okay. Since these are all subsets of R2, let me write these as 1 comma 0, 0 comma minus 1, 2 comma 5, 7 comma 2, or 0.5 comma 1 upon 7. These kind of some arbitrary finite set. Okay, have this. Okay, what is it? It is going to be somewhat here. It is 1 comma 0 point, right? And 0 comma minus 1 is going to be somewhat here. Let me name this as A, B, C, D, E. Okay, this is A, this is B, and 2 comma 5 is going to be somewhere here. This is the point C. 7 comma 2 is going to be somewhat here. 0.5 and 1 upon 7 is somewhere here. Okay, this is point E. Okay, in order to check this is open, okay, this collection is open, this set is open for all the points in a set, we need to identify some neighborhood. That neighborhood is completely contained in this set. Okay, even if I take a very small neighborhood except this point, none of the points in the neighborhood are members of E. So this point is not an interior point of E. Similarly, you can check all the points are not interior points of E. Therefore, it is not open. Okay, suppose some of you may ask, why can't I choose a point very close like this? Okay, this is also possible. Just identify the distance between the, even if you choose some neighborhood which is collecting this point, only this point is a member of a set, but this neighborhood has many other points which are not members of the set. So you cannot say this neighborhood is contained in E. This is not contained in E because this N has many other points which are not present in E. Therefore, this set is not open. Okay, now let us see whether the set is perfect or not. In order to promote a set to be a perfect set, it has to be closed. The first condition is it has to be a closed set. Okay, this is closed. The second condition is all the points of the set must be limit points of the set. Here, a finite set has no limit points. It does not have limit points even. Then how can we say these points are limit points to this set? So this set is not perfect. Okay, whether the set is bounded or not? Yes, of course. You can identify these distances. Okay. This P and Q are some for all P and Q in E. You can find these distances. Identify the maximum distance. Okay. Have that to be M. So this is your bound. A finite set is always bounded because we get this distance is always going to be some positive quantity. Okay, it will not go to infinity even if it is a very big value. Even we may have 10 power 1/5. Even we may have a value like this or even bigger than this, but these are all some finite values. So we can always find a bound for finite sets. Okay. Now, therefore, the set E is bounded. Okay. Now we are going for another example, that is set of all integers. The set of integers. How are we going to consider the set of integers in R2? This is 0, 0, right? So 1, 2, 3, 4, 5, it goes like this. This is 1, 0, 2, 0, 3, 0, 4, 0. It goes this way. Here -1, 0, -2, 0, -3, 0. You may consider these represents your integer, or you may take it the y-axis as well. It is up to us. Okay. We shall consider the set of integers in this form, in plane. Okay. Now we are going to check whether this is open, closed, perfect, and boundedness. Okay. We know that set of integers, let us denote that to be Z. Okay. Z is not bounded. That we are very sure of, because it goes till infinity, so it does not have any bound. Okay. See. Okay. What is a neighborhood in this plane? It is circle. Okay. If you select this point and try to find a neighborhood of this, whatever may be the radius, if you try to find a neighborhood of this, that will be some circle with that as center. Okay. You are going to collect some neighborhoods of this form. With the help of a neighborhood only, we are going to talk whether this is a limit point or not, whether this is an interior point or not. So in order to check these things, we need to find out neighborhoods first of all. Okay. If we choose some smaller neighborhood, this has many other points which are not members of this Z. So what? Z is not open. Okay. What about closeness? In order to be a limit point, it has to satisfy the condition what? All the neighborhoods. If I choose this point and take a very small neighborhood, I don't have any other point apart from this. So this is not a neighborhood. In a similar way, you can check all the points. Here, Z does not have limit points. If it does not have limit points, then what can we say? Since we don't have any limit points, we don't need to bother whether the limit point is a member of a set or not. In the previous example, what we have done, we have seen that a finite set has no limit points. If at all we have some limit points, we can talk whether that is a member of a set or not. Since we don't have any limit points, we don't need to bother about it and come to the conclusion that Z is closed. Okay. Next, what should we check? We have to check it is perfect or not. The same thing. It is closed, but it does not have any limit points. If at all we don't have limit points, we don't need to check whether all the points are limit points or not, because none of the points here are not limit points of that set. Therefore, Z is not perfect. Okay. Now we are going for another example. Okay, that is the set consisting of these entries. Yeah. N is any natural number. Okay. What are we doing here? Here we are going to consider the points. Let me choose this to be 0, 0 and let me choose this to be 1, 0. Okay. It is going to be 1 upon 2, 1 upon 3, somewhere. It is going like this way. Right? So we'll have to check whether this is a limit, whether this set is closed, open, perfect, bounded test. These things we'll have to check. Okay. So if it is 1 upon 2, then 1 upon 3 would be somewhere here. It will be 1 upon 4, 1 upon 5, and it goes this way. Right? Okay. Openness, closedness. In order for it to be open, what should be the case? If we choose any neighborhood, the neighborhood must be completely contained in the set. The points lie only on the axis. But when we choose a neighborhood, we will collect few more points which are not on the axis. So this set E is not open. Okay. This goes this way, right? This 1 upon 6, 1 upon 7, and it is coming, the elements of this set is coming very near to 0. Okay. But whether 0, 0 is included in this set? No. Because when we take n to be infinity, we will have 0, 0. Infinity is a quantity to which we can tend, but that is not at all reached. So 0, 0 is not a member of a set. Okay, let us try and identify the limit point of this set. Let me choose 0, 0. I can fix any radius, whether it is big or small, whatever may be the case. Okay. Let me fix R to be 0.0001. Okay. And I am trying to find out the neighborhood of origin with this radius. This is going to collect the points in R2 such that what? Absolute of y1 plus y2, because y1 minus 0 plus y2 minus 0. Okay. Square of these things, under root has to be less than 0.0001. Okay. So when you do a rough calculation, that gives you the circle. This is the circle that you are getting. Okay. So this is nothing but 1 upon 10 power 4. Can you identify some n such that your 1 upon n is smaller than this thing? Yes, of course, because your n can be anything, right? N takes the values in natural numbers. So this can also be your n. So your 1 upon 10 power 5 is smaller than 1 upon 10 power 4. This is smaller than 1 upon 10 power 6. This is smaller than 1 upon 10 power 7. Okay, if we add 1 upon 10 power 7 plus 1 plus 2 plus 3, it can be any value. All these values are smaller than this values, which means in this circle, if this is this neighborhood, this will have all of these kind of points. So in the neighborhood of, even if you choose 10 power 14, I can choose 10 power 15. Even if it is 1 power 40, 150 is there. Okay, 1 power 141, 617. I can choose many big values here, so that the value is becoming very small. I can identify many points of this set inside the neighborhood of 0, 0. Therefore, 0, 0 is a limit point of the given set E. Now, the question arises is that whether this point is included in the set or not. Just before I have told you that this point is not included in this set. So this set E has a limit point, that is the set has a limit point, but it is not a point of E. Therefore, what we can say, E is not closed. When a set is not closed, we can say that that is not perfect as well. Whether the set is bounded or not? Yes, of course. Here the value is lying between the 0, 0 to 1, 0. So the set is bounded. Here in this example, we can get a point. We can remark it there. We can remark it too. That is, there is a difference between a set having a limit point and a set having a limit point which is also a member of a set. So sometimes a set may have limit point, but that limit point may not be a member of a set. So there is a difference between having a limit point and having a limit point as a member. Okay, hope you have these ideas to you, and thank you for watching this video. If you have any queries, you can post it in the comment section. Thank you.